take your seats? Okay. If you need a seat and you're an Android, please take one. And then we'll get started. So, I kind of, this is a difficult intro for me because it's kind of basically a lot of what I do is his fault. Some years ago, I went in for a competition which we won, with rolling drones using Janus and with a lot of help from Lorenzo here. And I'm kind of blaming him for a lot of this, and subsequently he's helped me immensely in doing a lot of the stuff that we're doing with the little drones. Like I'll pop up on Twitter and say, how does this work? And he'll have an answer. So you're in the hands of a real expert, and so enjoy.
Thanks for the introduction, Tim. Yeah, I'll just make a presentation showing basically the effort that we did in migrating Janus to multi-stream support, and more specifically using unified plan. And if you don't know anything about that, I'll say a few words about that later. But before moving on, a few words about me. So I got my PhD at the University of Napoli a few years ago, and I'm currently the chairman and one of the co-founders of a company there called Mythico. I should probably eat more, as you can see from that picture. And as you can see from that picture, my mother threw away all of my Master of the Universe action figures 25 years ago, and I still can get over it. So sooner or later, maybe I will. And those are some contacts if you want to get in touch with me after this event. And Mythico in particular is a small company that we built as an academic spin-off. So we all did our research efforts at the university there. Eventually, we thought we could make some money out of the efforts that we've been doing there. And so now we're completely independent from the university, but that research background is still very strong in us. And we do several things, the kind of things that you can expect out of small consulting companies, so consulting services, support, and things like that. And this is where we live and work. So as you can see, it's a pretty nice picture over there. And don't forget that castle over there, because I'll get back to that towards the end of the presentation. Sorry? And a nice volcano as well, which is still sleeping, don't worry. So I'll give a quick introduction on Janus. First of all, how many not know about what Janus is? Okay, then I'll give a very quick introduction. So basically the idea is that it is an open source WebRTC server that's supposed to be as modular as possible in nature. It's open source, you can find it on GitHub, you can clone it, do whatever you want with it. We have some nice demos and documentations that you can play with before actually installing the component, and also a very active community on Google Groups. And the modular architecture typically means that we have a core that actually implements all of the WebRTC stuff. So it takes care of all the JSAP stuff, FICE, DTLS, SRTP, and all those kind of things. And then we have actually modules that take care of what to do after that part. So specifically, we have some plugins to expose the API that we provide to control Janus over different transport protocols, incorrectly calling transport protocols, but you get the gist. So we support, for instance, HTTP, WebSockets, but also other protocols if you're actually controlling Janus from the server side instead of from a browser. And most importantly, also the application logic. So what to do with the media that you get from a browser, or what to send browser back, is actually something that you implement in different media plugins. So typically the approach is people connect to these plugins via the Janus core using the API, and then the core takes care of the WebRTC stuff, so terminating the WebRTC connection, and plugins have access to the plain RTP and RTCP packets so that they can do something with it, which can be forwarding them somewhere else, implementing an SFU, or whatever actually makes sense for the plugin. And basically, the idea that we had at the time was that these plugins can be used as some sort of bricks that you can combine together in order to implement a more complex application. So you may want to implement something that uses a video SFU, but some SIP as well at the same time, and things like this. And just to give you an idea of how this works in practice, this is how you can see it working. So a browser connecting via some API to the Janus core, negotiating some PeerConnections with that, so you can see media going back and forth over those PeerConnections there. And in the background, these PeerConnections may actually be handled by different plugins at the same time, which makes it very easy to combine functionality coming from different plugins in the same application. And I'll give some details later on that. And this is made possible, of course, by the fact that the Janus API itself, the way that you talk to Janus, is actually modular as well, in order to allow different plugins to implement their own sub-protocol on top of that API. And this is all nice. It all works. It's been used by a lot of companies and people for the past few years with no problem at all. But we always had a known limitation, though, which basically means that since day one, our PeerConnection, so the WebRTC connections that you see, could only have one audio stream and one video streams in the same PeerConnection and max. So if you wanted to do 2 video streams in the same PeerConnection, you couldn't do that. So you needed additional PeerConnections to do the job. And this really never limited the Janus functionality in the first place. It just means that you need more PeerConnections to do the job and route multiple streams, but it is a bit cumbersome and can be problematic if the actual network resources are a bit of an issue for you. And there are several reasons why it might make sense to put them together. And you may wonder why we didn't do this at the time, so when we start working on it. And the problem is that basically Chrome and Firefox, as we'll see in the next few slides, implemented this feature, this multi-stream functionality in very different ways. And we really didn't want to implement both of these approaches, knowing that one of the two would eventually get thrown out of the bus because one would win. And so we decided to focus on the individual features instead, mostly because, as I said, in terms of functionality, Janus still can do whatever a component that supports multi-stream does. And just to give you an idea of what this means is that if we have a look at the SFU scenario where you have multiple users talking into a conference, for instance, the idea is that each user contributes their own stream just once, and this stream is sent to the other participants. Within Janus, this means that all of those arrows that you see need to be different PeerConnections if they are related to multiple video streams at the same time. So if the black user there wants to see the orange and green user, he cannot use the same PeerConnection for that. He will need a PeerConnection to receive the video from the green user and a PeerConnection to receive the video from the orange user instead. The problem, as I was saying, was the missing interoperability, and this was an issue for a while because I don't know how many of you know about the Plan B versus Unified Plan, basically duel, as we might call it, but there were basically very different ways of advertising this ability to have multiple streams in the SDP. More specifically, as we'll see in the next few slides, Plan B used a single M line per media type, while Unified Plan used different M lines for each media type. I'll show you some examples in practice just to give you an idea. And the former has been implemented by Chrome for a long time, and Firefox instead implemented the second from the get-go. Which means that if you wanted to have multiple streams at the same time, and you didn't have a server in the middle, there was no way you could get the two to talk to each other, basically, at least for the multiple streams. There was also another plan that was proposed some years ago, but it's never got enough traction, and actually it was always a challenge between those two ahead. And just to give you an idea of the differences, this is what a Plan B SDP looks like. And if we have a look at it, you can see, for instance, that in this audio M line, we see some SSRCs here, and here we can see that there is just a single audio stream over there. It's not the same for video, though, because in this case, we have actually 2 different streams. You can see 4 different SSRCs because there's also the retransmission SSRC in place, but the main idea here is that this video M line is actually carrying 2 different video streams that may come from actually 2 very different sources. So it's a single video M line, but actually representing more than 1 video stream at the same time. So this is one of the peculiarities of Plan B. And in fact, you can see the differences over here. These are the 2 different streams that are being negotiated over there. With Unified, instead, it's completely different. You see that each M line actually corresponds to a specific media stream that they are actually representing. So in this case, we have an audio stream, we have a video stream, and we have another video stream. In this case, there are separate M lines, so there's no confusion, no ambiguity there, as it would be in Plan B. And of course, as you can guess, especially at the time, there was a big debate between which approach should be used in order to implement this functionality, and eventually, more than 5 years ago, it was decided that Unified Plan was the way to go, even though, as you might know, it took a long time for Chrome to actually implement this functionality. They stuck to Plan B for a long time before actually deciding to implement it. Firefox implemented it actually very early, a couple of years later, but Chrome only started implementing it recently. But now that Chrome has actually implemented it and Safari is actually using it as well, I mean, it meant in layman's terms that we really didn't have any excuse. It was time for us to start implementing this, which is what we did. Eventually, we decided to implement Unified Plan to add this feature that was missing for a while. And I actually have to thank High5 a lot for this, because they were the guys that sponsored this development. It was a huge effort. It took quite a lot of time, and they actually sponsored the whole feature. So doing this on our own would have been hard, but thanks to them, it took much shorter than that. And it's actually still a pull request. So if you go and head over that link over there, you'll see all the discussions, all that is happening right there in terms of the different functionality that are there that may be still missing and so on. So what I'll do in this presentation is try to go and describe what we had to do in order to do this. So while this may seem very Janus specific, I really just want this to be also some sort of a set of brief guidelines for you as well. So if you are in a similar problem and you actually have to do something similar, what you see here may actually help you in not having as many headaches as we had basically for the time. So we had to do a few things in order to get this done. So first of all, we had to update our SDP functionality, because we had several assumptions in the code. Since we assumed always that we could have a top one audio stream and one video streams, if you look at the structures that we have in the code right now, they were basically very much reflecting these assumptions. So we didn't really care or have any way to address multiple video streams at the same time. We also had to support this ability to address these multiple streams in the core, which means getting rid of some hard-coded references and also be able to route internally these different streams so that we could basically know that the stream that is coming in comes from the third video M line rather than the second one, just to give you a practical example. We needed to add support for most of the plugins. I'll give you some examples later for what plugins we updated for the time being. Mostly because, as we've said, it's actually plugins that work on the media and know what they have to do with it. So they have to be aware of this new addressing functionality as well. And of course, we also had to take care of the client side, which I'll go at the very end of the presentation briefly. And so, I mean, I knew that we had a lot of things that we need to do, but we knew that we wanted to get this done. And so we started working as soon as possible on SDP first, because that's the main thing that we needed to fix. We needed a way to be able to parse an SDP, be able to figure out when there were multiple streams involved, and do the same for generating streams at the same time. So without bothering you too much with the details, those one video, one audio assumptions that we had were very much radicated in this SDP thing as well. So we updated that basically in order to change this kind of syntax that, as you see, had some very custom properties that specifically named audio and video without mentioning how many of those there might be, into something like this instead, where we could instead work on an M-line level and for each M-line address the specifics of the different properties of the media streams and so on. And most importantly, we also had to involve MIDs in there as well, because I have omitted this for the sake of brevity, but MIDs are very important in Unified Plan because those allow you to identify univocally a specific M-line in the SDP, and so allow you to say whether a remote or a local track is coming from a specific M-line in the SDP from an application level perspective, so both from Janus and from the user side. And of course, the same was done also for generating answers, so nothing fancy in that. So I'm not focusing too much on this because it's very code specific and I don't want to bore you. I want to focus on more interesting stuff instead. So for instance, like how we actually address the multiple streams in the Janus core specifically. So how we could identify an incoming stream and figure out to which of the existing streams this was supposed to be related to, how to pass it to plugins, how an incoming stream from a plugin could be sent to the right place and stuff like that. And of course, as you can assume, we had the same hard-coded properties for there as well, which meant that we had to actually do a bit of a refactoring on the internals there specifically. So it had an impact on media routing because first, at the beginning, we only checked if a packet was audio, video, or data, basically. Now we instead had to check whether it is RTP, which stream it belongs to, is an SSRC that we know of, do we need to use a RID or stuff like that. And we also got rid of some legacy code in there, and it's probably easier to understand if we have a look at this graph over here. So this is how it looked like before. So we had some legacy structures there related to streams and components that actually belong to the ICE language, if you're familiar with it. And this is because at the very beginning, Janus allowed you to have to not support bundle when you did WebRTC, which meant that you could have separate ICE properties for audio and video and separate ICE properties for audio RTP and audio RTCP. Eventually, we bundled everything so you can just use a single component instead, but those structures remained there, which meant that it was very much static and structured there. We had the stream that owned the component that owned some SRTP audio stuff and some SRTP video stuff, and then DTLS and maybe data channels. We changed that in order to be much more flexible instead, and so we created a macro PeerConnection structure instead, a manager that abstracts the PeerConnection information. And for each of these PeerConnections, we have different media instances instead. So anytime that a negotiation or renegotiation happens, we can update the information, add new structures, and so on. And all of those media there can be addressed by the MID, by the mline index, by the SSRC that is related to those, and things like that. So much more flexible, as you can see. And in principle, also addressing traffic was updated as a consequence. So again, not really just is it audio or is it video, but which medium of this list that we've seen here does this packet that is coming in belong from, and things like this. And so we had to update a bit the multiplexing. So first of all, we check if it's RTP, RTCP, or data, because that's what we already did before. But then for RTP and RTCP, we need to check which medium specifically this packet belongs to, because it may be the 5th video M line rather than the 3rd audio line, for instance. And we do that for either checking the SSRC if we know it. If we don't know the SSRC, we can check the MID and RID attributes, because as I've said, the MID attribute uniquely identifies an M line in the SDP. And browsers are actually now inserting this MID information in RTP extensions, which means that if we don't know the SSRC, we can just look at RTP extensions, check the MID value in there, and I immediately figure out to which stream this specific packet belongs to, which is really useful. And of course, we had to update the way that we address statistics as well. But one thing that may surprise you is that if we need to figure out the SSRC part, because in WebRTC so far, we always had SSRCs all over the place in offers and outers and so on. But just recently, actually, Chrome has started doing some new simulcast approach without advertising the SSRCs, which I won't go into the details of that. You can check that blog post over there to see why it's an issue and why it can be solved. But it is an issue that we did solve in Janus as part of the process. And as I was saying, plugins are very important and need to be aware of this functionality as well, because if the core knows about multiple streams but the plugins don't, then it means that we cannot really take advantage of that. So we cannot make a multi-stream conference, to make a very simple example. And so the first step that we had to do was basically update all the methods that handled RTP and RTP packets, both on the way in and on the way out, so that they basically would include this information about the M lines that I was referring to. So now, each time that the plugin receives an RTP packet that it needs something to do with, it can say, okay, this is the third video M line, so I need to do this with that because it corresponds to this specific user rather than something else. So this was the first step. But then, apart from that, everything else is up to plugins themselves. So for instance, SDP negotiation needs to be done via the approaches that I briefly explained before. So if plugins were using our SDP utilities to take care of creating an SDP and parsing an SDP, basically they had to update it in order to take advantage of these multiple features. And basically we decided to start just with a few plugins because for a few different reasons. The Echo Test gave us a very simple playground to test. The streaming plugin was basically a very easy way to test how broadcasting multiple streams at the same time would work. And the video room gave us an excellent playground for testing an SFU instead with the awareness of multiple streams at the same time. And I'll show you a few examples of them all. So we started with the Echo Test mostly because it was the simplest one to start with. And as you can assume from the name, it's just a plugin that whatever you send it sends it back on the same M lines that you used. So it was very simple to basically update it in order to be aware of multiple streams when you negotiate the SDP. And basically also involve the information about M lines whenever it does RTP routing. So anytime it receives a packet on the 5th M line, it sends this packet on the 5th M line back as well, which means that we should be able to see if exactly a packet is being routed correctly, both on the way in and on the way out. And it already works nicely. I mean, I'm a bit lazy, so I didn't update all of the functionality, like the ability to do simulcast on more than one stream. But as a proof of concept, it already does its job. So, for instance, if you have a look at how it works right now, this is how it would look like in the in Janus right now, in the current EcoTest version. What we can do now is add another video stream in parallel. Basically, I added locally a new video stream to send to Janus. This became a new M line in the SDP. Janus became aware of that and so created a new medium instance, and the plugin was aware of that too. I did the same to add another stream, and then I did some more, and then I did even more than that. And as you can see, it's always me, because if you're not aware of that, WebRTC developers have no friends. They always talk to themselves. There's no other people to talk to. But I mean, this just gives you an idea that on a single peer connection, I was able to get much more than that single video stream that I had before. So this was really encouraging, and so I started working on the streaming plugin as well. And the streaming plugin is a very simple but effective plugin that allows you to basically bind to some ports in the background, and whatever you send on these ports are actually sent on the WebRTC side. So think, for instance, that you have a GStreamer or an FFmpeg application that generates plain RTP packets. You send them to Janus, and Janus turns them into a WebRTC broadcast that a lot of people can watch, basically. And so this was a really interesting use case, because it allowed me to test multiple sources in the background and check if I could actually serve them all within the same peer connection. And so I had to do, of course, some updates as well for the same reasons that I had to do before. But most importantly, I had to update the so-called mount point internals. So a mount point is what we call a streaming plugin configuration. So a collection of ports that are related to a specific set of streams that we want to distribute. And so we basically updated this in order to, instead of just have an audio configuration and a video configuration, have different stream configurations instead, which was possible thanks to the new configuration approach that we have, which is not based on ini files anymore, but uses libconfig instead. And now, right now, it's much more flexible. The only drawback is that once you create that stream list, so if you say, for instance, I want 2 audio streams and 3 video streams, this is what you'll get for the whole lifetime of that specific mount point. If you want to update it, you cannot at the moment. It may be something that we will want to do in the future, but for the time being, this is it. And this is how it looks like when you actually configure it. So very simply, in this case, I'm creating 1 audio stream and 2 video streams, and I'm giving some properties to all of them. So for audio, I'm binding to a specific port, which means that whatever is generating the audio stream will need to send the RTP packets there. Same thing for video. I'm specifying the codec to use, also a label, because this label can be advertised and used on the client side. For instance, if this is a video surveillance application, this could be door A, door B, entrance, and stuff like that. So a very simple and effective way to configure something and then present it on the other side. And as a proof of concept, I basically created this. I was watching a video of the Napoli soccer team, which is the best soccer team in the world, if you don't know it. And I was watching some Iron Maiden video in there at the same time. So all on the same peer connection, which was kind of cool. I don't remember which audio stream I was getting, but it was probably Iron Maiden. So. And finally, of course, I mean, the main target of this whole effort was to make sure that the SFU plugin would take advantage of that, because that's the plugin that people use the most, and that's where the multi-stream support can actually really shine. And so this meant not only having multi-stream subscribers, as is the case of the streaming plugin, where we can have viewers that can receive multiple videos at the same time, but also multi-stream publishers, which means if I join a conference, I may want to send my camera and my screen sharing and maybe another camera at the same time. And this is something that we now can do with Janus thanks to this multi-stream support. And what's important is that all of the streams that the publisher now creates are unique streams that a subscriber can get. So you don't subscribe to a publisher anymore, but you subscribe to some of the streams this publisher has. It gives you much more flexibility in that sense. But the first decision that we had to make was basically that we wanted to keep publishers and subscribers separated. And what this means is that we don't create one peer connection for the SFU for a single user. So it might sound like a good idea, but we really thought it wouldn't be. So instead of creating one peer connection to send all our streams and receive all of the other streams, we decided to have one peer connections to send all our stuff and one peer connections to receive all of the other stuff. And there were a few reasons behind that. First of all, we wanted to avoid glare, and if you use always the same offer-answer pattern for these different peer connections, it's much easier. And more specifically, in our case, publishers always send an SDP offer, and subscribers always receive an SDP offer. So there's never the case of two offers coming in and basically we're having problems with that, figuring out how to solve glare and so on. So besides, it's much easier to handle in terms of the internal management of resources. It's much more flexible for us. And I had a lot of chats with some other developers as well. For instance, Iñaki from MediaSoup is doing the same thing in his platform, and I agreed with all this rationale, and so that's why we went for that as well. But what I want to stress out is that, of course, the old approach is still supported. So right now, when you use the Video Room SFU plugin, if you want to publish something, you have to create a peer connection. If you want to subscribe to others, as we've seen, you have to create separate peer connections. If you were okay with that and you still want to do that, you still can, because basically the API that we created allows you to create publishers and subscribers however you want. So if you want to have a separate peer connection to receive Tori and a separate peer connection to receive Giacomo instead, you're still free to do that. It's up to you how you want to actually combine these different streams in a single thing. But what's important here is that this is the diagram that we saw before. So before I explained how all of those arrows are separate peer connections. In this case, if you assume that sending peer connections and receiving peer connections are separate, then this means that this is the peer connection that we can use for sending stuff, and this is the peer connection that we can use for receiving stuff instead. So this basically means I only need 2 peer connections no matter how many people are in the room. In this case, it's just 3, but if it were 10, it would be exactly the same thing. I would still receive 9 streams over that single peer connection that I created, which is much better that way. So it's basically just 2 different peer connections to do the job. And I mean, for the rest, there were some updates that were also needed in terms of refactoring all of this information, the internal information, SDPs and so on. I won't bother you with all of that. But what's important is that now each of the features that we have in the Video Room plugin is very much stream specific rather than publisher specific, which means that we can uniquely identify, for instance, the 3rd video by this publisher because that's what I want to receive, rather than get all of the videos from this publisher and things like that. And of course, we updated the API and the configuration in order for this to be possible. And in order to allow people to actually test this, we created a new demo over there. The first demo that you see, the Video Room test demo, is basically the legacy demo, so the one that created separate peer connections for any stream that we sent and received. And that's still there because we wanted to show how it actually still works. But we also created another demo that instead uses just those 2 separate peer connections that I was mentioning. And most importantly, these 2 demos are interoperable. So if you join one or you join the other, you're still able to see exactly the same things. And I'll show you this very simply in these 2 screenshots over here. This is a screenshot of the legacy approach. This is me and Tobia and Paolo, who are other 2 people from Miteco, all in the same room, so the 3 of us. And this is using the legacy one. So these are 3 separate peer connections, one send only to receive only. And this is the multi-stream version. So what changed in the user interface? Nothing. I mean, it's exactly the same because functionally speaking, nothing changes. You still get the same amount of streams. What changes is just what happens in the background. So in the first demo, we had 3 different peer connections because I needed 3 different peer connections to send my stuff and to receive the other 2. In the multi-stream one, I only needed 2. And it's much more apparent, of course. I did a demo just with 3 people in. I could have done it with 6 people, and you would have seen many more peer connections up and just the 2 down. This is just really to give you an idea of how this all works. And so, I mean, so far it looked that everything was working correctly. But, of course, I mean, there were some things that still weren't, so some things that needed to be taken care of. And one of those were actually data channels. And the Video Room in particular was an interesting use case for that because our SFU also allows you to send and receive data channel messages from other participants. And when you have separate peer connections, it's much easier to do that because if I subscribe to Team and I receive a data channel message on the peer connection that is associated to Team, I know that that message comes from Team unequivocally. There's no doubt about that. But if I have a single peer connection to receive 20 people at the same time, and I receive a data channel message, I may not know who this message belonged to. At least I couldn't do it with the way that data channels were implemented in Janus at the time. What we did was basically add support for multiple streams and labels at the same time in data channels, which was something that we were missing. We only supported a single one that was created either by Janus and by the user. Now instead we support multiple streams and labels, and more importantly we use, probably wrongly, but we use labels as the identifier at an application level, which means that, for instance, in the video room, if I need to send a message that belongs to Tim rather than to Tori, I basically in the video room create a new a new data channel stream that has Tim's unique participant ID in the conference, and I send the message there. At the application level, I will receive this new data channel stream. I will see that it has the ID associated to Tim. I will know that all the messages I'll receive on that specific data channel stream actually comes from Tim. And basically this allows me to do pretty much the same thing as we did for audio and video. So multiplexing messages coming from different sources over the same channel without having any ambiguity with respect to who a message belongs to, basically. And to conclude, basically the last step was implementing the client side. And I won't focus too much on that because it was basically the client side part is typically done by other people most of the times. We have an example in Janus.js as a way to implement proof of concept or not, but most people implement their own clients rather than use our own. But we still needed to update our demos to use all of that, of course. And the biggest change was implementing transceivers, which, again, if you're not familiar with the unified plan lingo, is pretty much the way that what you need to use if you want to use a unified plan accordingly. Because basically, and I'm oversimplifying, these transceivers are a way to uniquely identify a sender and a receiver in the SDP, because each transceiver is uniquely mapped to a specific M line. So when you want to add an M line, you create a new transceiver, you assign an MID to it, and you know that each packet that is coming from there and going out of there is actually associated to that specific transceiver, which allows you to have much more flexibility also in terms of updating the media direction. So for instance, putting a call on hold in the zip word and things like this. And of course, we had to make sure that the browser did support this, because we wanted to still support browsers that were not using all of this stuff. And so we had to add some checks to be sure that we were not using this where we were not supposed to do that. And Chrome specifically may need an explicit way to do that, because there are some versions of Chrome that may decide to use Plan B or Unified Plan randomly, depending on some internal logic, especially when they were actually first shipping this functionality. By specifying that you are specifically interested in a Unified Plan, you basically avoid this randomness and are sure you are always using the right thing whenever you need it. And the second step was basically to make sure that we could also handle the incoming streams the right way. So in the demo that we've seen before, for instance, where I had the echo test with seven different streams in there, I had to have a way to basically know a new video stream to which M line it belonged to, so that I could couple it with the local track and so on. And the only way I could do that was basically to start working on tracks rather than on streams. Because again, before it was much easier. I had only one audio stream and one video stream max, which meant that I could just work on media streams instead, and it was much easier. Here I cannot do that anymore, so I have to work on tracks. And so now Janus.js notifies you anytime a new track comes in, a track is muted, it goes away, and stuff like this. Basically, very easy and effective. And of course, we use the MID as a way to identify each track specifically from an application perspective. So if I receive a non-remote track with MID 5, if I have a look at the SDP, I know exactly to which stream this belongs to. And most importantly now, each track is also played in a separate element. Before, when we got a non-remote stream, for instance, we would play audio and video in the same video element, which can be a problem if video is not coming in for some time and audio instead comes first, because you may have noticed that in that case, some browsers won't even really play the audio at all. If instead we use separate elements, so for instance, an audio element for audio and a video element for video, it all starts working because they are all independent contexts instead, so much easier. We still need to do, let's say, some fancy way of adding local and remote tracks locally, so for instance, adding a new webcam in my PeerConnection, but really nothing more than that. I'm almost done, by the way, so basically, all of this very long and boring discussion was to tell you that basically the effort is done. We are probably going to merge it soon. Right now, we are in maintenance mode, so we get feedback from people. If they tell us that there is something wrong, we fix it. The JavaScript code, of course, needs some more love, but I'm lazy, as I've written in more on one slide. But of course, there's always room for improvement. So in the futures, there are many things that we could do. For instance, updating it to different plugins, start implementing some new scaling mechanisms and stuff like that. But most importantly, the reason why I brought this here was I wanted to bring these new efforts to the community here. And if you are already using Janus, please start playing with this stuff because it will be merged soon. And so you definitely want to start practicing with that. If you've never played with Janus before, it's really the best moment to start is now. So just start playing with that. Try and use the new functionality that we have. It will all be cool. And before I conclude, just a quick shameless plug here. So we are organizing a conference in Napoli in September. So in a few months, you can see it's already being sponsored by a few companies. If you're interested in sponsoring yourself, just get in touch. And it's basically, it will host some presentations on Janus and WebRTC in general, but also a VoIP on the Beach event that will basically address some VoIP information in general. And it's right in front of that beautiful castle that I showed you before at the very beginning. So we are right on top of the sea, very beautiful, very nice. So if you've never been to Napoli, there's no best opportunity to do that. And of course, there will be pizza because I'm contractually obliged to tell you that there will be pizza. So this is all. I don't know if there is any time for questions or if I went beyond my time. Just a second.
Twice in your presentation, I think first you said you couldn't add and remove streams, and then you said you couldn't dynamically add and remove tracks yet. So how does that work for the SFU conference? If new people join, does that mean you have to create a new media connection instead of adding them to the existing one?
Yeah, basically the way that it works in the SFU is anytime a new user publishes something, or maybe an existing user adds a new video stream, for instance, we notify using the signaling channel about these new streams that are available. So then it's up to the application to decide whether they want to subscribe to these new streams or not using the existing PeerConnection that I have or possibly a new one. So they basically send a new request to the video room API and say, please add this video stream coming from this guy with this specific ID. And you will receive a new offer with a new M-line with the video in there, or possibly also reusing a video M-line that was used by another guy before that has then gone away. Because the video M-lines can also be reused if they are unused in here.
Okay.
One more, maybe?
Can you define glare? I've seen it in a couple of docs for the STP.
Yeah, it's basically glare is that problem when you get two competing messages of the same nature. For instance, in the SDP, if you are in a call and you send an offer and your other party sends an offer at the same time because you both wanted to update something at the same time, then you are a bit of in a pickle because you don't know who actually had some precedence or another and so on. So there are ways to address this from a standards perspective, but I really didn't want to bother with all that. I mean, I really wanted something that was much simpler and much more streamlined, so something I could have more control on. I know that this will always offer, I know that this will always answer, so I'm never going to incur into these problems because I'm always having to have control over that.
I think this is the last question, and the most important question. Is Hawaiian pizza good or bad?
It's definitely bad, and I'm thinking of creating a new social event on the second day that will be explicitly called No Pineapple Pizza event. So we are still thinking about it, but that may happen. Thanks, everybody. Thank you.